Hi, my name is John Crockmolney, and I've developed these virtual tutorials to accompany any technical training format. In this series of basic physics, we will explore scientific notation, why it's used, and how to do it. The applications of scientific notation are found in a wide range of engineering, medical, and scientific areas. The learning outcomes for this tutorial include number one, describing scientific notation. Number two, explain why scientific notation is used. Number three, convert decimal numbers into scientific notation. And number four, convert scientific notation to decimal numbers. When we consider flow rates of water, we may think of GPM, which stands for gallons per minute. The GPM term measures one value involving two conditions: quantity in terms of gallons and time in terms of minutes. Looking at gallons, we can consider it as being a container for liquids. Electricity also has a flow rate, and the electrical term used for this flow rate is amperage. The amperage term is also representing a value involving two conditions of quantity and units of time. A coulomb can be considered the container for electrons, similar to gallons is a container for liquids. We know by experience about how much water a gallon measure holds. What then is the size of one coulomb? The size value of one coulomb is stated here. Notice the size of this number and where the numbers are placed in relation to the decimal point. This number represents a very, very small value, less than 1. Scientific notation is used to express numbers that are too big or too small to conveniently write in decimal form. Converting the number answer, we can state that the size of one coulomb is 6.240A, which stands for atto, which has a numerical equivalent to the real number. Let's refresh our understanding of our current numbering system. We use numbers in counting and calculations. We also consider numbers to be related to a value of something. Currently, the world uses the 10-based numbering system. In a 10-based numbering system, everything starts at 0 and builds from there. In this case, 0 is nothing. Realize that 0 could also indicate a value too. Building on this 0 value, we increase numbers up to the number 9. These could be considered the base unit numbers. As we increase numbers beyond 9, we start additional columns to the left. Notice that staying with the 10-base numbering system, we establish columns of tens, hundreds, thousands, and more. Considering these columns, we can determine the number of the greatest significance are to the left. Numbers with the least significance are to the right. Notice that these values are greater than the base unit of 1. For fractions of the base unit of 1, we can then move toward the right and assign columns of numbers significance. We can understand any value in tenths, hundreds, and thousands. Let's start with the most basic number, 1. This number of 1 could also be understood at 1.0, a single digit without any additional fractions assigned to it. If there were additional fractional numbers, such as 1/4, these would be added to the right of the decimal, making it 1 1/4. Referencing where the decimal point is, any digit located to the left of this point is the greatest significant number, and those to the right, the least. In current technologies involving science and math, it may require the use of large numbering values. Notice that the listing measures are in rather large numbers. Scientific notation is used as a convenient method to convey the meaning of very large numbers. Using scientific notation starts with the number 1. This number 1 can also be understood as 1.0, one value of something without having any additional fractions added to it. We call this the base unit of 1. Any number above this base unit of 1 increases or becomes greater than 1. Any number below this base unit of 1 decreases or becomes less than 1. Considering 1,000 of something, we see the addition of zeros to the right of the base unit, the number 1 followed by 3 zeros, and then the decimal point. In scientific notation, the term kilo is assigned to the value of 1,000. The capital letter K also signifies kilo. If you see the number 1 followed by the capital letter of K, it is meant that 1,000 is the intended value. In the exponent column, we see 10 to the third power. This number 3, in this case, is assumed to be positive in value. We can use this term to understand where to place the decimal point and how many zeros to add for conversion of scientific notation value to the base 10 number. In this example, 1K is rewritten with a 1 and 3 zeros added to the right of this 1, followed by the decimal point. 1,000 is written in scientific notation as 1K, and 1K is written as 1,000. Following this same format, the next higher value would include million, represented by the base unit of 1, followed by 6 zeros. Notice that the prefix of million is mega and can be abbreviated with the capital letter of M. The exponent is identified at 10 to the 6th power, also an indicator of how many zeros to add to the base number. Using scientific notation, 1,000,000 can be shortened to 1 capital M. 1M can be converted back to a 10 base value by placing 1 and adding 6 zeros to the right, followed by the decimal point. We can follow the same pattern, applying it to billions. Notice that billions involve 9 zeros. A computer hard drive could hold 1,000,000,000,000 bytes of information. Using the scientific notation, we shorten this to 1G, G for giga, indicating billions. Converting from scientific notation to 10 base, we write this number 1 followed by 9 zeros placed to the right, and then place the decimal point. Notice the abbreviations following scientific notation are in capital letters above the value of 1. For those abbreviations of less than 1, we will use the lowercase letters. In this graphic, we will create a value of 1,000th, a value of less than 1. 1,000th is identified with a prefix of milli and is abbreviated with the lowercase m. We can write this value as 0.001, 0 whole values, and 1,000th of another. Looking at the exponent column, we see 10 to the power of a negative 3. This is an indicator of how many zeros are involved and where to place the decimal point. The number 0.001 can be converted to scientific notation by moving the decimal point 3 positions to the right and adding the lowercase letter. Doing this, we write the number 1 followed by a lowercase m. Converting this 1m to the 10 base value involves writing the number 1. Because there are 3 zeros applied, the decimal point is moved 3 zero positions to the left of the number, followed by the decimal point. A millionth of something will be identified with a prefix of micro and abbreviated with a lowercase u letter. Looking at the exponent, we see 10 to the power of -6. Again, we see that 6 zeros are applied to the process of scientific notation conversion. Converting the value of 0.000001 to scientific notation involves moving the decimal point right 6 places. We now have 1 U or 1 micro. Converting this to 1 micro back to a 10 base value, we write the value of 1 followed by the movement of the decimal point 6 places to the left. Looking at billionth of something, rather than writing it out in the entire value, we can use scientific notation to provide a code to convey large meaning numbers and values. Summarizing the conversion process, any number greater than 1 can be identified with capital letters as an abbreviation. Numbers smaller than 1 can be identified with abbreviations using lowercase letters. Scientific notation then provides a code that allows values to be written in convenient ways. Considering the value of 1 million, the unit of 1 with 6 zeros erased and substituted with a capital M means million. The scientific notation value of 1 capital M, erasing the letter M and substituting with 6 zeros to the right, converts this to 1 million. Now may be a good time to apply what is being presented here. What would a nominal capacity of a 520 G hard drive on a computer be? Feel free to actually stop this presentation, work out the problem, and arrive at the answer. Notice that 520 G is written in scientific notation as 520 10 to the power of 9, or involving 9 additional zeros to the right. Adding these 9 zeros to the right of the root number of 520 results in the number of 520 followed by 9 zeros, indicating billions. Since 520 billion is just a number, we have to apply this value to some quality. In this case, the 520 billion is the amount of bytes of memory storage capacity. Let's try another problem. A resistor measures 1500 ohms of resistance. What is the value of this resistor in scientific notation? Again, feel free to stop this presentation, work the problem, and arrive at a solution. A good first step would be to locate the decimal in the proper location. In this example, the decimal is located at the end of the last zero. Notice that 1,000 of something involves a scientific notation of 10 to the third power, or involves 3 zeros. In this example, the decimal of 1500.0 is moved 3 positions to the left, resulting in 1.5. Adding the capital letter of K indicates that the 1.5 is in thousands. Again, a value without some identification about what it refers to is incomplete. In this case, the 1.5K value is associated with ohms, the term for electrical resistance. When it comes to resistance, keep in mind that the higher the value of resistance, the more opposition to the movement will result. A resistance value of 0 offers no resistance and therefore uncontrolled flow or movement of something. A capacitor is an electrical component that stores electrical energy. A capacitor is listed as 0.001 PHY1A010 farads. What is the scientific notation for this value? In this case, we're dealing with a value of less than 1. Notice that the micro prefix is associated with the scientific notation of 10 to the negative 6 power. Here we see the use of 6 zeros, and the decimal will be placed to the right of the existing decimal place. This action results in number 10. The abbreviation for micro is the small lowercase u and is placed at the end of the number. The term farads is associated with the number indicating value of capacitance. The answer to this problem then becomes 10 small u, understood as micro, farads. An instrument indicates 12 MA. How many amps is measured? The small m represents milli and a thousandth of something. Scientific notation is 10 to the negative third. Rewriting 12 with 12.0, we install 3 zeros to the left of the decimal point and move this decimal point 3 places to the left. The scientific notation of 12 MA then becomes 0.012 amps. In summary, scientific notation represents a type of scientific shorthand and making complex numbers more readable, especially on scientific and engineering drawings.